Conditional probability. Suppose a study of speeding violation and drivers who use cell phones produced the following fictional data. Use cell phone while driving. 25 got a speeding violation and 280 got no speeding violation. Do not use cell phone. 45 got a speeding violation and 405 got no speeding violation. To simplify the table, we will let A be the event that the driver used cell phone while driving. Then not A means the event that the driver do not use cell phone. We let B be the event that the driver has a speeding violation. Then not B, its complement, is the event that the driver had no speeding violation. If we do that, then we now have a simplified table with 25 and 280 in the row with A label, 45 and 405 in the row that is labeled with not A. When we are presented with a two-way table, we should always add up the total in its rows and in each column. 25 plus 280 is 305. 45 plus 405 is 450. 25 plus 45 is 70. And 280 plus 405 is 685. If we add the last row and the last column, we should get the same number. 70 plus 685 is 755, or 305 plus 450 is the same 755. Now, given that the driver used cell phone while driving, what is the probability that the driver got a speeding violation? We are interested in the probability that the driver got a speeding violation, but only out of those who use cell phone while driving. Out of those who use cell phone while driving, how many of them use cell phone while driving? 305. And out of these 305, how many got the speeding violation? This means that if we restrict our attention to row A only, because row A represents the number of drivers who use cell phone while driving, then we see that 25 of those got a speeding violation. So this is 25 out of 305. This time, this probability is not out of or divided by the grand total. When we restrict our attention, or when we focus on a particular row or column in the two-way table, we're looking for what we call the conditional probability, because this probability has a condition. We're looking for the probability that the driver got a speeding violation, but with a condition. And what is that condition? The condition is that the driver used cell phone while driving. To denote the conditional probability, we would use the vertical bar. First, we use the uppercase P for the probability. The probability of what? The probability that the driver got a speeding violation. We let B be the event that the driver got a speeding violation. So we're looking for P of B, but not just P of B. Again, this probability has a condition, and we use the vertical bar to state the condition. The condition is that the driver used cell phone while driving, and that is the event A. This equals 25 over 305. The number 25 comes from the part that the event A and B have in common. And the number 305 is the total of the row A. Similarly, if we're looking for the probability that the driver used cell phone while driving, given or with the condition that the driver had a speeding violation, then this time around, we're looking for the probability that the driver used cell phone while driving. This is the event A. So we're looking for P of A, but again, with a condition. What is the condition? The condition is that the driver had a speeding violation, and that is the event B. To find this probability of A given B, we focus our attention on the column with B only, which is out of 70. And out of these 70, which means out of those who had a speeding violation, how many of them used cell phone while driving? And that is 25. Similar to the previous probability, the number 25 comes from the intersection, or the part that the event A and B have in common. A, B, and 70, the number in the denominator, comes from the column B. This time, column B. Earlier, it was row A. Again, every time we focus our attention on certain row or on certain column, we're looking for the conditional probability. We can also solve the conditional probability using the Venn diagram. Using the Venn diagram, we first draw a rectangle that represents the entire sample. In this case, there are 755. And then we draw one circle to represent one event. There are two events that we are interested in. A is the event that the driver used cell phone while driving, and B is the event that the driver got a speeding violation. What they have in common, meaning the part that they use cell phone while driving and get a speeding violation, is 25. This is the intersection between the two events. This is what they have in common. This is the overlapped part in the Venn diagram. Recall that there are 305 drivers who use cell phone while driving. This is the entire circle A. And there are 70 drivers with speeding violation. When we're looking for the probability that the driver used cell phone while driving, which is A, given that the driver had a speeding violation, which is B, we're taking the part that they have in common, 25, divided by the part that had speeding violation, which is 70. In symbolic form, this is the probability of A and B, what A and B have in common, divided by the probability of B. And so this vertical bar reminds us that we would need to divide its probability. And again, 25 is the number that comes from the intersection A and B. And 70 is the number that comes from the circle B, the entire circle B. Similarly, if we're looking for the probability that the driver got a speeding violation, which is event B, given that the driver used cell phone while driving, which is event A, we took 25 divided by how many of those who use cell phone while driving? 305. Symbolically, this is the probability of A and B divided by the probability of A. And again, the vertical bar reminds us to divide its probability. This is what we call the conditional probability.